Hello and welcome for joining me, or thank you for joining me on this guided project. Today we're going to be taking mobile prices and we're going to use Ensemble methods to do so. So I've already imported our amount in my Google Drive. I like to work, my students know, I like to work off my Google Drive account off the cloud. It's just so much easier. I'm going to import libraries. Today we're going to work with the add a boost classifier, random forest classifier, random boosting classifier, and bagging classifier. We're going to import the standard scalar and the train test splits. So let's import those libraries, and then we'll start by importing the data frame. So using pandas.read CSV and then just your file path. Mine's a little bit long because I have a lot of projects on the go, and so yours probably won't be this long, but your file path here to import the data frame. So the first thing we do to generate this nice little printout right here, we really want to make sure that we inspect our data and that it is what we expect it to be. So we'll go df.head, and really all we're doing here is this a correct file that I wanted to load up? So yes, okay, everything makes sense here. Nothing really more than that. This does seem to make sense to what we were expecting. The next thing, another really common process, or what I like to do next typically in my workflows, is really analyze the data types here. So to get this printout right here, we'll go df.info and then parentheses. And what we'll do is it'll give us a nice printout. We can gather two things from this, is the number of non-null values. And so if this was changing, we would know that there would be some null values that we would need to inspect in more detail and then likely fill before we put our workflow into a modeling, go into the modeling workflow. We also have the data types here. Now, today it's going to be an easy one in terms of data types. We're all floats and integers. Those generally behave the same, although in certain situations, no. But for most of the cases, we'll be able to do math in the same way on a float or an integer, and that's really what we're concerned about when we go into the modeling workflow. If this was an object, if one of these was an object, we would have to handle things a little bit differently. Even the way that we would inspect our data in the EDA would be a little bit different. So there we go. So we can see we have no null values and we have all numeric columns. So starting off the EDA section, our exploratory data analysis, I like to just get a good quick summary of our numeric features, which is all of our features today. So I use the df.describe, and this describe will give us a 5-point distribution, so min, 25th, 50th, 75th max percentile, and then mean as well, and the count. And we can see that we have 2,000 across the board, so we're pretty good there. What we'll do is then inspect our distributions. So what we'll do is for feet. I like to do this as a loop just to make it a little bit easier. So 4 feet, F-E-A-T, in df.columns, and this is the list of all of the column names. So with this, we can just loop through this. So because we all have numeric features, this makes it actually a little bit easier. We can go sns.displot, and we'll go data equals data frame. And then what we want to do is x equals feet. So what will this will loop through for battery power, and then for blue, for clock speed, for dual sim, and it will plot the distributions of each one of those. So let's just, and what I'm going to do here is actually give it a title just so that we don't get mixed up. So we'll go plot.title, and then we'll give it the title of our feet, not of our feet, of our feature. Just is a little bit clear when we print this out. So sorry, it's going a little bit slow. I'm running another workflow in the background. So you can see here we get a nice plot of all of the distributions. We can see battery power is generally uniform. Blue is either a yes or no, so it's a one hot encoded category. Clock speed, dual sim, FCS. We can see it's a little bit of, not exactly an exponential, but not a normal distribution. We would need to deal with this in a way for our modeling. Uniform for int memory, semi-uniform for dep, mdep, mobile weight, again, uniform as well, and core is more or less uniform, PC, more or less, not exactly uniform, but more or less uniform, and then our px height has a little bit of an exponential flavor to it, let's say, when we're looking at that distribution, and we can see another uniform, semi-uniform, and a slightly uniform or slightly exponential distribution as well. So we have generally the same things. We have a slight imbalance in the G3, and that this would be one hot encoded. So the ones would make up the bulk of this, which is kind of what we would expect for mobile prices. They have the G3 or 3G. I think it's 4G now. So the ones that don't are the minority, which is to be expected. Touch screen, Wi-Fi, price range. And so this is our target category. And we can see we have an even number of 0, 1, 2, 3, which means we have an even sampling for a target variable today. So these are the observations. I won't read through all of these for you, but it's good to just read through these quickly and make sure you understand what I mentioned here. Very, very simple, right to the point, uniform distribution, uniform weak exponential distribution. So it's just really good to understand exactly why I put what I did there. Okay, so bivariate. So let's do a very simple, very quick bivariate analysis. So let's go SNS dot pair plot. And what we want to do is we're going to give it the df, and we're going to set hue to the price range. And then the palette is going to be crest. I really like crest. It looks a nice blue-green kind of color. So if we go df hue crest, and let's get this to run. This is going to take a few seconds. Okay, so we finished that took a little bit, but we finished the pair plot, and this gives us a good detail. It's a little bit busy, so it might be good to actually do this in a couple sections, but we can gather quite a bit of detail from this if we were to inspect this one by one. Again, it might be better to do this in smaller sections because this is quite a large plot, but we can even see here we're noticing a pattern where we can start to see the impact of the different colors because we did the hue is the price range, so we can see here very clearly across the RAM has a big effect, has a very high correlation with the price range. So we'll pay attention to that as we work on the rest of our workflow. So the next thing that's really important to do is looking at your heat map, looking at the correlations in your data set. So we would do this using a heat map. And so what we can do is we can go SNS dot, well, you don't have to use a heat map, but a heat map looks pretty nice. So we'll go heat map, and we're going to give it our data frame, but not just our data frame. We're going to go df dot corr, so correlation, corr. And then what we're going to do is we're going to go cmap, and we're going to also look at the color crest as well. So let's run this. Get a nice little printout here, and we can see here we've got a nice little title there as well. Plot.title, and I added font weight bold, and you can do font weight italic, and you can do a few different things as well. But this is a nice little printout. What we can see here is that with our price range, just like we noticed up above in the pair plot, RAM has the highest correlation with price range. So something that important would be a very good feature in terms of how predictive our model would be. We would want to make sure that we keep RAM. Okay, so another thing that we can do is let's just confirm the amount or the impact each one has on our data set. So we can see here we have a nice little plot here, and we're just going to use pandas plot. So what we'll do is we'll go df.core cor with, and what we want to do is we want to give it a series. So we'll go df price range. So df price range. And then because this is going to give us a kind of random order of that, we'll go dot sort underscore values, just so that we have a nice ordered plot. And then we'll just call it using a pandas plot. We'll go dot plot kind bar. And this works because it's using pandas plotting function. And so when we print that out, we get a nice little plot. Let's actually go, and you can see here we can do this going to the larger correlation. So RAM has a perfect correlation, or sorry, price range has a perfect correlation, which would you would expect. RAM has a very high correlation, much higher than all of the other features. And these kind of ones, the clock speed, M depth, and cores seem to have nothing to do with our predictive or target feature. So even the negative is good. Negative is still a relationship, but when there's kind of a non-existent relationship, these M depth and core's clock speed would be features that we could start by taking out. So those have the lowest correlation. So this is a quick, easy way to inspect our data, and we have a good sense of what's related now to our target. So let's head into the pre-processing section.